All right, hello everyone. Welcome back to the last video for this unit. We're going to be talking about squares, properties of squares in this video. So just like the last two units, what we're going to be looking at here is how we use segments of diagonals to determine if a quadrilateral is a square, rectangle, or rhombus. So properties of squares are going to contain every single property of parallelograms, rectangles, and the rhombus. So every side is going to be in a square, all the opposite sides are going to be congruent. They're going to be parallel. All of the opposite angles are going to be congruent. Every consecutive angle is supplementary. All of the diagonals bisect each other. We have 4 right angles. All of the diagonals are congruent. We have 4 congruent sides. The diagonals are perpendicular, so where they cross, they make a 90-degree angle. And then the diagonals bisect opposite angles for this one. So with squares, this one right here, we're going to fill out this entire square and see what kind of values we can find just by what is given. So we first start with AD, which is 11. And we know that these corners are 90-degree angles. So I'm just going to go ahead and fill in that this is 45 because that's half of 90. And then this is 45 because we know that the diagonals bisect the angles. Okay, so we start here with BC. BC is the opposite of AD, so that's going to be 11. Just looking at a few other things, we have AC, which is the diagonal piece, and we don't know what this piece is, so we're going to find it real quickly. And the way that we do that is we use the Pythagorean theorem, kind of like what we did with the rectangles. We're going to use the Pythagorean theorem to find this. We know that AB is 11 and DC is 11. So our two legs are going to be 11 squared plus 11 squared, and that's going to be equal to AC squared. Okay, now there's actually another way that we could do this, and it involves special right triangles. In our 45, 45, 90 formulas, we can use those formulas to actually solve this problem, but I'm going to show you both ways. So AC here is going to be equal to 242 AC squared. When we take the square root of this, AC is actually going to be, let's see here, 242 square root 15.56, 15.56. Now, if you use the special right triangle formulas, we know that the legs are equal to X, right? Leg is X, and then the hypotenuse is X times the square root of 2. So the easy way to do this would have been to say, okay, we're going to use these formulas. AC is equal to 11 times the square root of 2. Okay, that means that BD is going to be the same length because it is also a diagonal. And then for EC, EC is half of BD, or EC is half of AC. So we have AC divided by 2. When we plug in AC, we have 11 square root of 2 over 2. And all we're doing here is just dividing 11 by 2, which gives us 5.5 times the square root of 2. So if you just wrote this down, that'd be perfectly fine. If you want to multiply it out, you can do that as well. Or you can just leave it like this, because technically that is the simplified version, right? So I'm going to leave this in simplified form to get our answer. That takes care of all of the sides. For the angles and squares, okay, we already filled out some of these over here. That should help us with these guys. So DAB, that's a corner. All corners are 90 degrees, the full corner at least. AEB, so AEB. Okay, we know that on the inside, we have perpendicular bisection. So that's going to be 90 degrees. CBD, and that's one of these corners here. It's half the corner, not the full corner. So that's bisected, that's 45 degrees. And then BAC, that whole angle also got bisected. So that one's going to be 45 degrees as well. Squares are real simple, probably the easiest out of this unit. Okay, here, number 11 is wanting us to figure out what X is. Okay, so to do that, we just need to take this whole corner, which is 90 degrees, and use this 90 degrees to say that it's equal to 2 of these guys, because it's bisected, right? This 90 degree is bisected by this diagonal. So the 7x plus 3 is going to be the same length as this, okay? And the reason that we need that is because we only know that this corner is 90 degrees. All right, so here's the work shown. If we set it up that way, we have 2 of the 7x plus 3's, which is equal to 90. If we divide by 2, that gives us 45 is equal to 7x plus 3. Subtract 3 on both sides, then we have 42 is equal to 7x. Divide by 7, that gives us x equals 6. Now, the other way that you can do this is, since you know that this is bisected, you could simply just say that 45 degrees, which is half of 90, is equal to 7x plus 3. And then that's going to give you the exact same thing, where you have 7x equals 42, divide by the 7, you get x equals 6. So either way that you choose to do this is fine, but the shorter way is to recognize that at first, this angle right here is a 45 degree angle. That would make this problem go by super fast. That's all for this unit. Good luck on the test. See you in the next one.